We're on page 18. What page are we on?
18.
Nice. We're on page 18. We're going to title today's notes Reactivity. We alluded to reactivity a little bit at the end of last week. All right, the top half of your notes, we're going to sketch a periodic table. The bottom half, we're going to draw two Bohr models. All right, so let's get the left side, the bottom. We're going to go over and down one, over and down about two. And we're going to make these transition metals. We're going to kind of make them, well, not kind of, we're going to make them way shorter than normal so we can address groups 13 through 18. All right, do you remember what element this is? Bless you.
Thank you.
Okay, we have hydrogen. All right, and we're going to put a little roof over hydrogen because groups, remember, groups go up and down, periods go side to side. Groups are also known as families, so let's put a little rooftop over that family as well. Okay, the element we're going to do a Bohr model of in just a minute is called lithium. Can you guys remember the name? It'll be just super special if you can remember the name of these, of group 1. What is it? I think you got it really close. Alkali. I heard you say it. Everybody said it. You just didn't say it loudly enough, right? Okay, so these are the alkali metals. All right, group 1, this is group 1A, right? Every element in this group is going to have one valence electron. So every element in group 1 or 1A is going to have one valence electron. Group 2A, how many valence electrons? All these elements will have 2. All right, then we've got group 13, 14, 15, 16, and 17. Let's put a roof over those. Every element under 13, or it's called 3A, will have 3 valence electrons. Does that make sense? 4, every element in group 14 or 4A would have 4 valence electrons. And then we're going to get over here to group 17, which is going to have 7 valence electrons. And today we're going to do a Bohr model of this one right here. Y'all remember the name of this one? Yeah, fluorine. Okay, special group, these guys are called halogens. And do y'all remember the special name for these guys? Good. The noble gases. Okay. The noble gases are stable. We're going to write the noble gases are stable, which means they never react. Okay, the noble gases are stable. They will never react with any of the other elements on the periodic table. Nod your head if you got that much. Okay, we're gonna do a Bohr model of lithium and a Bohr model of fluorine to show that. Okay, let's draw the element box of lithium first. Atomic number is 3. Its symbol is Li, and its mass is 7. Show me thumbs up, over, or down if you think you could do the Bohr model right now. Let me see here. Okay, I see some of you already have thumbs up. You could do it. All right. So we're going to draw a nucleus, right? Okay. Inside the nucleus, we're going to put 3 protons. Now, if the mass is 7, how many neutrons do we need? Good. We need 4. So that covers our mass, but we need to make this atom neutral. So we need 3 negatives for every positive.
So we need 2 clouds.
Yes, we need 2. We need 2 energy levels. That's good. All right. Now we can't squeeze that third one in here. So we're going to put this one out here all by itself.
So it has only 1 valence.
It has 1 valence electron, okay? How many does it need to have a full outer shell? It needs 8, so it's missing 7, right? All right, so now we're going to come over here and we're going to draw fluorine like we had right here. Okay, fluorine is in group 7, correct? 7A, I should say, or 17. Fluorine has 9 protons. Its symbol is F, and it has a mass of 19. All right, we're going to draw our nucleus. And inside that, we would have 9 protons. The mass is 19, so we need to get this nucleus to 19. So how many neutrons? Nice. We need 10. Okay, that gives us a positive nucleus. We need negatives out here. So we'll draw the cloud. 1 energy level. Show me fingers. How many electrons will fit?
2.
Show fingers. Nice.
So we need 1 more outer shell.
We need a second energy level, right? And the second energy level will hold up to 8. But we don't need all 8, do we?
We just need like 7.
We just need 7. Okay, so we're going to do 1, 2, 3, 4, 5, 6, 7. All right. You notice lithium has 1 valence electron? What group is lithium in? In the alkali metals, 1A. Every element, if we did a Bohr model, all of these elements would have 1 valence electron like lithium, okay? Look at fluorine. You guys said fluorine was in group 17 or 7A. How many valence electrons did fluorine have? 7. if we did a Bohr model of all of the elements here, they would have 7 valence electrons, okay? All right, now here's what happens in nature. The other elements want to be like the noble gases. They want a full outer shell. So lithium cannot do that on its own, can it? And fluorine cannot do it on its own. How many electrons does fluorine need to have a full outer shell?
More.
It needs 1 more. Guess where it's going to get it? Lithium's going to slide over here, okay? And combined, these two would make something called lithium fluoride, and I probably spelled it, no, I know I spelled that wrong. But together, they would share that electron, and they would come up with something called lithium fluoride.
And what does it look like?
It would be a bond, it would be a chemical bond. So by bonding, and that's what we mean by reactivity, these metals, the alkali metals, are the most reactive metals, and the halogens are the most reactive nonmetals. You want to make a note of that? These are the most reactive metals, and the halogens are the most reactive nonmetals. Can y'all read that?
What's lithium fluoride use?
That would be something we would look up on Google. And that, my friends, is how the elements bond to become more like the noble gases. Thank you, second period.